Welcome back to the third lecture on the policy options in shaping the future. A quick recap of what we discussed in the previous lecture. We identified 3 different dimensions that have to be addressed by policymakers in shaping the future: the physical, the social, and the institutional dimension. We briefly discussed the physical components that are needed, or at least some of the physical components that are needed in a world with an increasing share of electric vehicles and variable renewable energy sources. But we also had a look at the social dimension, and we already introduced the concept of complex, adaptive, socio-technical systems. So then it's time to turn to the third dimension that is needed to shape an electric and sustainable future: the institutional dimension. The institutional dimension represents the rules that govern the interactions between the system components. Institutions can be formal or informal, and they can apply to different levels of the system. And mind you, institutions are not to be confused with physical or social structures. It is all about the rules that define the game and how the game is played. Informal rules may be derived from generally accepted norms and values of a society, such as they are linked with sometimes age-old customs and traditions. Formal rules may be embedded in law and regulation or in contracts. Formal rules may dictate, for example, that power grids are regulated networks under public ownership and that energy services are to be provided in a competitive market. Formal rules also define whether charging infrastructure provision is a regulated public utility service or a commercial service. Institutions are man-made rules, in contrast with the laws of nature that largely govern the behavior of the physical system. However, even in the physical system, institutions play an important role. Prominent examples are operating and maintenance procedures and technical standards. In the world of electric vehicles, to just give you that example, multiple standards exist for charging infrastructure. For fast charging, 4 major standards are currently being used worldwide. There is the European CCS standard, the Japanese JEDIMO, the Chinese GBT, and the standard developed by Tesla. Of course, all 4 standards deliver the same electricity to the car. But multiple standards lead to additional hardware costs or to reduced accessibility of charging infrastructure for electric vehicle drivers, since charging stations do generally not provide for all 4 standards or for more than one standard. Now, you should not be mistaken. The setting of standards is not a very straightforward matter of technical optimization for safety and user comfort. Standard setting is generally a lengthy process of negotiation between public and private stakeholders, in which really huge economic interests may be at stake. You should therefore not be surprised that many infrastructure systems are still a long way from the ideal situation of a single standard. Think, for example, just one example of the different railway gauges around the world. Just last summer, I crossed the border between Mongolia and China on the Trans-Mongolia line, and it took a 5 hours wait to change the train wheels from the broad gauge system in Russia and Mongolia to the standard gauge in China. So standards, if they are different, may bring a lot of discomfort to the users of systems. Another example of how institutions matter is concerned with the processing of charging transactions. As you can see in this image, the transaction at a public charging station involves many different actors which communicate through a large variety of technical standards. But in this emerging market, the roles of each actor are not yet set in stone. This slide shows the situation in which a charging station can be operated with a charging pass, owned by a mobility service provider. The charging point operator and the mobility service provider communicate via a clearinghouse to validate the transaction. But some actors in the field are advocating the use of ad hoc payment solutions in which different actors are involved, while still others prefer using a mobile phone app, which replaces the role of the mobility service provider. And at this point in time, it is still very uncertain which of these options will turn out to be the winning one. Similarly, there are still many unknowns in smart charging. As previously discussed, smart charging entails the alignment of battery charging with the supply of cheap electricity during times of low demand or during times of abundant supply from renewable resources. The role of aggregators is to aggregate the charging demand of a collection of electric vehicle owners to the extent that they can bid in different markets, ranging from a local market for local load management to the provision of balancing services to the regional or the national transmission system operator. And it is not yet clear at all which rules and communication protocols shall apply to the interactions between these actors. And it is evident that institutions are badly needed to ensure that all actors will be treated fairly and that the system as a whole delivers positive outcomes for society. To wrap up, during these lectures, we have discussed 3 different dimensions which need to be aligned to bring a zero-emission power and mobility system into being. The physical system changes required will not happen unless actors in the social system decide to make the required investments and disinvestments. And to make that happen, the institutional framework of the power and mobility system will need to be revised. Thank you.